We are live now. Right. Can you see everybody
Just
see my
about.
main screen? Yeah. Everybody see the slides up on the screen? Yeah. Brilliant. Okay. Okay. Welcome everybody to this, which is sort of like the first of our a new series of Thames River Basin Lunch and Learns. Yeah, we'll shortly hear from James Hubbard from Action to River Kennet. But before we do that, I just want to go through some of the meeting etiquette and also the background of why we're here and sort of like plans for future meetings. That's okay. One highlight, just as it says on the screen there, bear with us before we go any further. Sort of like this is our first time of running one of these sessions, so please bear with us if there's any sort of technological hiccups. Those of you that are at Thames Catchment Forum on Tuesday will know a combination of myself, PowerPoint, Teams, and new situations is an interesting sort of place to be in terms of challenging me. But hopefully we'll be able to iron over any sort of like technological hiccups. Etiquette, please can you put yourselves on mute when not speaking. Use the chat to ask questions or share any thoughts. There'll be an opportunity at the end to ask James any questions. Raise your hands, obviously, if you'd like to speak at that stage. Importantly, be respectful of everybody's contributions. Keep your camera on if you're comfortable, but obviously some of you are having your lunch and you don't need to share that with us, or you can share it with us if it's a very nice lunch. Leave that up to you. And please, if you can, try and stay present, avoid multitasking when possible, just to kind of enjoy, sit back and, enjoy James's presentation. It'd be fantastic. Just to remind those people who are joining at the moment that we are recording this. And so, yeah, just please do take note of the meeting etiquette and mute yourselves. It'd be fantastic. Just moving on. Have we gone on to the next slide? We move to the next slide or not? No? Oh, let's do it this way around. There you go. Housekeeping. Okay. As I say, the sessions will be recorded. Slides and materials will be shared afterwards. We will also look to put the recording and the slides onto either Thames Rivers Trust website or maybe even onto the Rivers Trust website as well. But we'll put them onto a central location so they become sort of like a resource for yourselves. Why are we doing this? Well, we've been working with the Rivers Trust, Thames Water and the catchment hosts, as well as a wide range of other stakeholders in the Thames Basin, exploring ways to sort of like improve communication between the partnerships. Why do we want to do that? Well, because it sort of avoids duplication, builds trust, shares learning, saves time, sparks new ideas, strengthens bids, solves problems, and supports joint action. So, and it's kind of part of a wider package of work we're doing with all the different catchment hosts and catchment partnerships, looking to kind of bring them together through a variety of different tools and mechanisms, such as more regular meetings, newsletters, etc., and shared platforms to share information and learning on as well. What we've got upcoming in the future, so there's a series of presentations lined up already. We've got Rob Collins comes to talk to us about catchment planning. Then we've got Tessa Wardley, also from the Rivers Trust, to talk about new water policy. We then have a break for summer, and then we're going to move on to farming relations with Jenny and B from Farming and Wildlife Advisory Group. Then Sam from ZSL will be talking to us about outfall safaris, landscape recovery from Tim on the for the Northeast Cotswold Farm Cluster. And then we've got a series of presentations on biodiversity net gain with Carolina, Lucy, and Adam and Tom. We've got one date in the diary in December, but we might try and put another date in the future. Most importantly, kind of what we want to do, we just want to hear from you, your ideas for presentations. So either kind of drop those ideas into us at that email address there, info@thamesriverstrust.org.uk, or just put your ideas into the chat or let us know just generally. But yeah, no, these are kind of for you to share. So kind of tell us what you want to hear about or anything you want to share, and we'll kind of arrange it and we'll slot a date in. Okay, that's probably enough waffling for me. We'll pass over to James shortly. So what are we hearing about today from So we're hearing from James from Action from the River Kennet. James has been at ARK since 2024, which seems to have flown by. There's a project
Yeah, and a
officer.
little.
Yeah, it's project officer of Pang, and also the Kennet too. Oversees community engagement and citizen science, and is leading on their developing their water quality work. Supports river schools, supporting river schools, and James leads on conservation tasks from balsam bashing to river restoration and supporting the team. So, James, yeah, are you ready to take over now? And yeah.
Yes, no, all good to
I'll hand
go
over
ahead.
to you.
Shall I see if I can share? Thanks for watching the intro, Miles. And yeah, pleasure to be kicking off the first one. How is that on screen share? Oh, we've got one too many screens, so I've got to see if I can actually find everyone. But that's showing up all right? Good.
Can people
Thanks,
see it?
folks.
Yeah,
Yeah.
it's very good.
Okay. Yes. So as well as being project officer on the ground, increasingly sort of hosting the monitoring group within the Pang flagship chalk stream partnership. So yeah, as project officer for the River Pang, this is a chalk stream, very rare, as I'm sure you're all familiar. There's only 260 odd of them globally, and about 220 of those are in England. But yeah, the Pang was designated a flagship chalk stream in 2022 as part of the catchment-based approach chalk stream strategy. Thanks, Charles Rangeley Wilson, one of 12 of them. And recently, yeah, it's been getting some momentum, finally getting some things delivered on the ground, thanks to funding from Thames Water and wider sources in the partnership. So been sort of coordinating all of that to get it going. But the main thing I'm going to be talking about today is our approach to monitoring, in particular citizen science monitoring, looking at water quality. So although it's a beautiful chalk stream, it very much has had its issues over recent years. It's sort of noticed by locals and river keepers and everyone who's been there long enough to see it decline over the last 5 years, that there's been a change in the patterns in the water quality towards the river generally being more turbid as you get downstream, and the colour changing quite drastically. And yeah, I'll be talking about sort of our process of investigating this and wider water quality issues within the area. If you give me 2 seconds trying to figure out, we've got something funny going on with slides. Should be all good. Okay. On to the next one. How's that? Stuff. Yes, so Action for the River Kennet covers, of course, the Kennet, which runs from Silbury Springs out west of Marlborough to its confluence with the Thames at Reading, but also the Pang, and that's sort of my main domain, heading from West Ilsley, East Ilsley, Compton, down through Saul and West Berkshire towards Pangbourne, where it meets with the Thames here, just to set the scene. And as we're all familiar, I'm sure, yeah, all rivers need good habitat diversity, chalk streams, same as any others, and flow diversity to go with it, all of the right vegetation in the right places. So both in-channel aquatic vegetation and marginal, which supports all of the river fly life that we see there, and then in turn, trout, otter, yeah, supports the full ecosystem. And a lot of that is dependent on water quality at the base of it. So river fly particularly sensitive to water quality, oxygen levels, metals, turbidity, sediment, settling over them. And then ARK also believe that the public and citizen scientists should have the opportunity to see the river and to be involved in its restoration, and for it to very much be a community-based process to restore the river. So we do a lot of citizen science activities. We get people out on the ground. This is from Water Bowling Day, but also have been having citizen science monitoring led by some people within the community. So despite being a beautiful chalk stream, it does have its fair share of challenges. So historically, we've had a real issue with abstraction. In the 90s, thankfully tackled one of the major abstraction points right at the source of the River Pang, so up in Compton, which has significantly improved how frequently it stays flowing. Flow diversity and barriers, so right down at Pangbourne, again at the mouth of the river, or where it joins the Thames, have major things like Environment Agency gauges, which come with weirs and can block a lot of coarse fish as well as salmonids. So we'd like to see that restored to natural structure. Fair share of invasive species, things like signal crayfish, mink eating all of our vole. And the thing I'll be focusing on today is, of course, clean water. So excuse the slightly poor photo quality. One of these is from 1908. So I think their cameras were a little more coarse back then. And the other one was taken on a riverkeeper's rug while he was having a brandy in his house. He'd been working on the river for the last 60, 70 years. So very familiar with how it used to look some time ago. And the main thing is that the water quality and its clarity has really dropped. So compared to its sort of crystal clear habitat and a lot of crowfoot, particularly further down the river, it sort of pretty consistently looks like this top right photo at the moment. Actually, thanks to the last couple dry months, it's generally been a little better. But when you get down towards the lower reaches of the river, you end up with water quality that doesn't look much like a chalk stream. Towards the source, generally a little better, but there is this pattern of the bed accumulating sediment, of the water having this sort of grey-brown tinge quite frequently. And that sort of flagged this as a topic of concern initially, and led to citizen science investigations. It's not something that has a clear pattern in where it emerges. So just from visibility alone, sort of looking for where we find pollution, it's very much something that it's not necessarily closely linked to surface runoff, in that when there's a lot of rainfall, you don't always see a spike in turbidity further downstream. Often it'll be dry weather for a long period and you'll still have that brown colour. Likewise, the point that it starts at also varies quite a lot. So the good old-fashioned method of looking at the river, lining it up with sort of recent rainfall, and trying to figure out sort of any patterns and where it's coming from, hasn't been enough on its own to identify sources of pollution. So we've got, as I was saying, our fair share of challenges on the Pang, particularly when it comes to water quality. The river is unlucky enough to start with 2 wastewater treatment works as its source. So at the moment, Compton Wastewater Treatment Works is the source of the River Pang, and quite often it will be even further downstream at Hampstead Norris. But yeah, effluent begins the river. The quality of that effluent is relatively unknown. Environment Agency monitoring has had 2 regular sampling points on the river and does test for things like suspended solids and I think biological oxygen demand. But it's relatively infrequent. There's a bit of a lack of information on these sources. We've also got 2 points where the M4 crosses the river, which comes with its own challenge of this slightly grim particulate matter. So all the tyre wear particles that work their way in, mix in with God knows what of metals and PAHs and potentially cancer-causing chemicals. Yeah, it's a real issue, and we've done a bit of investigation into that as well recently. And then on the sediment front, we do know that a lot of sediment gets in towards the upper reaches, and this is something we've slowly been piecing together over the last year, and is now really picking up to actually pinpointing where some of these sources are and beginning to think about what we can do about it next. So to set the scene for our citizen science, Mike Wilson, Professor Mike Wilson from the University College of London, who's had a long and star-studded career in microbiology for the last 30 years or so, decided, he lives on the River Pang at Frilsham, and decided that something needs to be done, so set up his own monitoring with support from ARK. So he's a microbiologist by trade, and wanted to look at not just the bacterial side, but also water quality in terms of chemistry. So set up with support from ARK and a few other, in terms of buying equipment and a lifelong chemist, Barry Murray, who's put in a lot of work as well in getting this all established. Set up 5 monitoring points along the length, covering the majority of the main channels, so 12 miles of the 14 miles of its length, including one comparison from upstream and downstream wastewater treatment works, just to get an idea of if that's having an impact, but broadly sort of covering the full reach of the river. And using quite standard citizen science methods, but towards the higher end where possible, things like these Hannah checkers, which are quite effective at giving specific readouts, but of course done with quite some rigor. And so actually how I first got involved with ARK about 2 years ago now, when this was set up, was as a volunteer with Mike Wilson and Barry Murray, going out and about testing the river. So the parameters that we were testing were, and still are, we initially did it weekly, but now do it monthly 2 years later, because it's quite a commitment at all 5 of these locations, covering conductivity, total dissolved solids, very similar, pH, dissolved oxygen, temperature, nitrate, phosphate, ammonia, and nitrite. So those last 4 are all nutrients, or linked to nutrients. And then also uniquely, 3 indicators of bacterial counts. So using McConkey dip slides, quite a low cost method for about £1 for each of them. Mike got a very effective incubation setup where could dip them in, come back to them 2 days later, and you'd get a good readout on density of different microbes, so the total bacterial counts, coliforms and Escherichia coli. So both coliforms and E. coli are generally good indicators of pollution from effluent, and that could be either through human wastewater or through cattle. If I run through some of our initial questions, give a bit more of an idea around what we're aiming to do. So the plan was to get both an understanding of the chemical and microbiological conditions, so not quite a status, but an understanding of where the river was at that had a bit more resolution than the Environment Agency's testing, which is once a month at 2 points, just due to their capacity constraints, and to cover quite a range of parameters at the same time. And then to compare it with regulatory standards, so to see sort of how that varies relative to WFD standards using their thresholds, and see if it's improved or deteriorated. So again, comparing to WFD data for the last 10 years, and then comparing it to other English rivers. So to run through a few of the findings quickly, the way the river works, because it's a chalk stream, groundwater fed primarily, conductivity at the top end of the river starts very high. Note that the axis doesn't go down to 0 here, so this isn't much of a decline, but towards the top end of the river, it's groundwater fed, springs bubble up in Compton, Hampton Norris, various places along its length, and then it slowly gets diluted by some additional surface water, effluent possibly coming in as we go down, and we saw that reflected in the conductivity readings. I'm not going to go through all of these because it might not make for the most exciting talk, but the most promising thing was found that dissolved oxygen was actually across the board really quite good. So identified that for a chalk stream, it was at the level we'd expect to see it. The only terms and conditions apply to say on this is that most of our testing at the point of these summaries was looking over winter and a summer that hadn't been too hot. So this was following on from 2022, when it was a really dry, really warm summer, when conditions might be quite different. Whereas the year that we were looking at, summer was more traditionally British. So the overall a good picture of its health on the oxygen front. Nitrate, because again it's groundwater fed and we're a nitrate vulnerable zone and have historically a lot of nitrate loading from agricultural activity within the catchment. That's led to accumulation within the groundwater. So the river, right from its source, starts with very high nitrate concentrations and interestingly drops as you go down it. Effectively, this means that as a nutrient, nitrate is never limiting within the river, so it's unlikely to constrain things like algal growth, and instead that's more likely to be dependent on other nutrients, in particular phosphate. So looking at those phosphate levels, this is where we found the most discrepancy with the Environment Agency readings, and also found quite consistently high readings across the board. When we compare them to the mean for English rivers, again, similar readings to where you'd expect other rivers to be, but as a chalk stream, there should be a low nutrient habitat, and it was quite concerning to see quite how high they were coming out. And this is using HANA HI 713 low range phosphate checkers. So based on the phosphate concentrations, our sample classification came back as classification based off of the Environment Agency's thresholds, using mean as a reference, came back as mostly moderate and quite a few poor. And that implied, looking at all of the data, that phosphate should be the target. So a quick summary of the findings, as I was saying, dissolved oxygen is high, conductivity generally within range, ammonia levels were generally low. I've got sort of, if you're interested to see more information on ammonia, nitrite, etc., at the end of this time. But also saw generally high phosphate concentrations, high nitrate concentrations, and high nitrite, which is so a second form of ammonia once it's when it's degrading, and is quite a good indicator of recent pollution. And then high concentrations of both coliforms and E. coli. So E. coli counts in the thousands, total bacterial counts in the millions, coliforms also quite abundant. Can't initially say where these are coming from, but can say that it's probably not the best idea to swim in the river, and there's definitely some form of effluent, whether that's from cows or from treatment works, which of course don't actually treat for E. coli or coliforms, yeah, throughout its length, the river has quite high levels of both. Got a lot of public interest from this, so presented about it at public events to things to residents of Pangbourne and beyond within the catchment, and also had our local MP for West Berkshire and Reading, Olivia Bailey, come along to the lab. And yeah, she's been very engaged. It'd be really good to see her speak recently in Parliament about some of our findings and the condition of the Pang, and really put chalk streams on the agenda, which has been very good to see. So thinking about those phosphate readings in particular, that was something that was flagged as potentially being more significant. Comparing to the source apportionment GIS modelling that's been done, I think it was initially an independent research group that came up with it, and then it's been implemented and shared by the Rivers Trust for 2024 here. And it implies, yeah, that it takes into account things like river flows, outfalls, and regulations around their concentrations for things like wastewater treatment works, amongst others. So also different land use in the area. Plugs in all the numbers and gives you an estimate. It's very much an estimate, but an idea of nitrate and phosphate concentrations. And it suggests that most comes from sewage treatment works. And given that, again, there's one up here and one down here, perhaps not surprising that would be the case, and that the river starts probably not very nutrient limited. I do need to mention we had a testing day with the Environment Agency where we went out in the field side by side, took the same readings for different parameters, and at exactly the same location using the same samples. Generally, our readings came out almost spot on, so plus or minus 10, 20% for almost all the variables. For one of the phosphate readings, it came out spot on, and then for the other one, it came out substantially higher from our own. So we do have some suspicion about, at the moment, about the HANA phosphate checkers and their potential to bump readings up. We've excluded readings above a certain threshold, and also used Koreatsu phosphate test, which are effectively the ones that Freshwater Watch use, but bought in bulk to do some comparisons and to sort of double check, because it uses an enzyme which is really specific and lets you get around that issue by double checking if you get a high reading. It is worth probably having some consideration around the accuracy of these kits, but for the most part, they give you a very good picture of trends, and we do expect the catchment to have something of a nutrient issue along its length, because we see a lot of diatom growth both on the riverbed and potentially in the water column as well, given its colour. This is a slightly cheery quote. Water is the canary in the coal mine of climate change. I think one of the things to think about is that we are expecting we're seeing it at the moment. We're going to have a 29-degree day today, I think it is, at its peak. And as conditions warm, as there's more sun, not more sun, as the river gets warmer, and you have high nutrient levels and consistent sun hitting it, you are more likely to have these impacts around perhaps not eutrophication in chalk streams, but definitely drops in oxygen levels, algal growth, which can all have impacts on crowfoot, on the riverfly communities, and I think it's definitely worth being prepared for this in the future by making sure that if we can limit anything, we limit the right things. So just thinking about how it all interacts within rivers, within the Pang in particular. We can't really do anything about the nitrate levels. It's going to take about 30 years to flush out the system. Whereas phosphate, we have continued inputs, and then it sort of moves on through the river. We're not exactly sure what those inputs are, but we have a pretty good idea. With the two together, definitely impacts crowfoot growth. It sort of grows too quickly. It's holdfast. The root at its base weakens and then can get swept away. We've seen downstream of the treatment works pretty bad algal growth and diatom blooms, but it's not exclusively in those areas. Across the full length, we do occasionally have this sort of diatom growth around them. Which leads to less habitat from vertebrates, less oxygen from aquatic plants, generally worse conditions, and you can have direct nutrient impacts if you get those algal blooms happening, ultimately harmful to invertebrates and fish. And it's good to remember why you're aiming to make improvements in water quality in the first place. So that's sort of the nutrient side at the coarser spot sampling level, and off the back of that allowed us to purchase a pair of in situ Aquatrol 600 sondes that test similar parameters based on our own spot sampling. So these take readings every 15 minutes. I've got a pair of them deployed in river, and currently upstream and downstream of the Hampstead Norris wastewater treatment works. They're relatively low cost in the scheme of SONs, but very accurate, and you can have calibrations for them. We have had a few issues with a couple of them where there's a bit more discrepancy, but found that if before deploying them, you stick them in the same location side by side, so they're testing exactly the same water, it allows you to line up what they're testing and then see if there's any difference before you deploy them in the field. So it's a very effective way to make sure that there definitely is no difference between their readings if you're going to do a comparison upstream and downstream from the point source. So in this case, you can see temperatures spot on. You can't even see the difference between the red and blue lines, red being upstream, blue being downstream wastewater treatment works. Turbidity is more stochastic, but again, generally reading quite similar. Oxygen saturation, indistinguishable apart from a single point. You do occasionally get these one readings that pop out slightly different, but you can ignore them if it's just a single reading. If it's multiple in a row, it's worth considering. Conductivity, a bit of a gap, but then because you can see there's that gap, it allows us to account for it from looking at the actual readings. Likewise, nitrate, ammonia, generally we find that the levels downstream of the treatment works were lower than upstream. To begin with, the SONs, before we deployed them and had them at the same location, they were reading lower for the one that was downstream than for the one that was upstream, if that makes sense. So then actually, when we deployed them upstream and downstream, this is just showing a little snapshot over around 10 days, found that there's quite consistently this elevation during the day in temperature downstream that you don't have upstream. It's only a different distance, about 150 meters between the two, so it shouldn't be enough for the river to warm significantly as it flows along that length. So could be linked to effluent. Looking at oxygen saturation, get a stronger peak and trough, and that kind of daily variability and that fluctuation can itself be an issue, and is usually an indication that you're likely in particularly hot weather to then have more of an oxygen crash, which can ultimately be harmful. Turbidity, it's harder to make many conclusions. It doesn't seem to be the main contributor over this period, but we need more data to determine. And conductivity, again, these sort of individual drops, and that's mostly down to calibration. Inconveniently, at I think it was halfway through May 24th, a cow chewed through the cable for one of my SONs. So we don't have any downstream monitoring from that point. But yeah, back up in the field and running since then. It is always worth considering where you put it. So cows can cause problems. So then looking after deployment, do find quite significantly elevated nitrate levels below the treatment works than above. Likewise, very significantly elevated ammonia, not to hazardous levels, but definitely some coming in. And pH, again, that's mostly down to calibration. But given that before deployment, that was well below, likewise, ammonia was well below, definitely is elevating levels. One thing that came out of this monitoring with the SONs was actually, while one was deployed within Hampstead Norris, we found this quite dramatic spike in turbidity immediately after rainfall. So in January, when they were deployed earlier in the year, there were 2 centimeters of rain fell in quite a short period, and you could see this huge jump in turbidity within the river. And upstream of there, there's quite a lot of arable farmland, and it did seem like a lot of runoff was working its way in. This is a whirlpool in Hampstead Norris, the village where my parents live. I never thought I'd say it, but full-on whirlpool running straight into a surface water drain that then goes into the River Pang directly and takes a lot of sediment with it. So we weren't 100% on where this was coming from initially. It sort of indicated there was definitely an issue in that section, but we needed to investigate. So been training up some citizen scientists. We've now got a crack team of about 10 of us who go out and about and do monitoring within this mud spotter process. So this was developed by Queen Mary University of London. Effectively, it's sending out citizen scientists to go look for sources of sediment, track them down, and then map them. And to figure out where they're getting into the river and work your way back up the catchment to actually figure out where the source is so that you can do something about it rather than just finding its point of entry. And it's shown that the problem initially does seem to be concentrated towards the top end of the catchment. There's quite a few outfalls that run directly into the river. And using tools like the Environment Agency's alert tool, I'd really recommend just as a free mapper for things like surface water runoff. Really good for giving detailed small-scale catchments. all of that side of things to figure out where flow is expected to be. Looking in practice at what we're spotting on the ground, when we actually went out and go to some of these points where you predict flow pathways, where there is good cover from vegetation, generally you don't actually see much runoff, even on arable sections. It might be bare earth, but it will generally trap it over if there is no sort of hard standing surface. But if you get tracks, if you get fields next to roads, that's where we're seeing much more of this runoff, and it does seem to be quite accurate. So you will get sections where there's not an insubstantial amount of runoff. So for example, along this road over here, saw a huge amount after dump of rainfall, just it was turned into a full-on river running across a predicted flow pathway. Drove over there, checked to see if it was indeed happening, and did, yeah, could see a lot of flow coming through. Likewise, some tracks down there, but for the most part, it seems to be concentrated in the top part of the catchment on this arable land. So yellow here is arable cover, and we've seen particularly there's a lot entering around Competent, upstream of Hampstead Norris, so right at the source of the river, and you get this repeated pattern of water accumulating in fields towards the top end, running its way down tracks, continuing down tracks, picking up sediment, picking up momentum, and more water as it goes, work its way onto roads where it can really sort of channel along. And it does seem to collect some from verges as well in a few places. And then I think this is a little video, if I can, it would be nice if I could play it. Oh, there we go. Bubbling up out of surface water drains that it works into, and getting onto the road systems, joining other surface water drains. You might be able to hear some thunder in the background as well. And then ultimately getting pretty directly into the river. Mid-January, there's hail on the ground as well. It's one of the perks of the job. So outfall of sediment directly into the river, and this does seem to be the most common pattern, is field to road to surface water drain to river, and we're seeing that quite commonly. So think about the road network. As I was saying, we're a bit unlucky on the Pang in that we do have the M4 cross it twice. Good if you need to get anywhere, but less good for road runoff. So this is the M4. This is a little gutter at the top of it. Snaps a photo of in the middle of rain. That colour is not from the tarmac below. That is effectively black. And looking at where it's working its way in, and you can't quite see it in this photo, but this one really illustrates it. There are outfalls that come pretty much directly from the M4, work their way into the river, and all of this seems to be coming off the surface of it. Upstream, entirely clear, downstream, properly coloured, and these massive plumes of presumably very toxic. We actually have some samples, these 3 samples at the moment in the lab. No prizes for guessing which one's from which. There's an upstream, there's downstream, and then there's directly, adjacent to the outfall where it's coming out over here. And it's not just sort of brown, it's not just mud, it's probably a lot of tyre particles, brake particles, all the rest of it. Currently in an external laboratory, ALS, has an environmental service that can do testing for that and sediment, and getting them to cover all metals in the meantime: zinc, copper, mercury, all the things that are most toxic to river fly and freshwater life in general. If you want to sample for PAHs, important to note that you need to use glass vessels. In this case, use plastic, and the time of collection was a bit short. It was a last minute plan, but covering metals, but do use glass if you want to test for PAHs as well. We've also got a bit of an issue with some developments in the area. So this is, again, in Compton during heavy rain. There's an animal health testing centre up in that direction. Always a bad sign if you're banned from growing root vegetables in your garden. But everyone in that area for the last, since the place was shut down, has been forbidden from growing anything in the ground they're going to eat, off the back of metal accumulation in the area. And we're seeing at the moment that there is runoff coming through the site while there's some works going on, and they're getting again directly into the river. So where a few slides ago we had those surface water drains at that short film, showing runoff coming in into drain and into the river. The river is about 5 meters in this direction, and you can see quite clearly where it's working in. So the mixture of sand and chalky water, but yeah, major development, about 160 houses going on at the moment, or looking likely to go ahead. And as a small rivers trust, there's only 5 of us in total. We don't really have the capacity to think about working with planning on the planning and development front, and hope that perhaps that's something that the wider Rivers Trust could support on in the long term if they had a planning and development officer. At the moment, we're just sort of monitoring, keeping an eye on it, making sure that all is proceeding as it should, and there are sort of standard checks to avoid this kind of runoff. So to try and pull all of this together, we're also setting up a monitoring working group at the moment. As I was saying, the Pang flagship chalk stream partnership has picked up some momentum recently, and I think the main thing with any monitoring is that you're making sure that you're doing it in a targeted manner, and that you're answering a question that you can do something about, and also gathering data that hasn't already been collected. So it is always important to have a bit of a baseline with things like Mike Wilson Citizen Science Monitoring. It's provided a proper insight, but off the back of it, if we'd done a little bit more investigation into the Environment Agency's data, it definitely would have given us more context before beginning to then sort of pick sites. It's offered a real insight working with the EA as well, where possible, to sort of compare readings. And given a much more detailed picture, actually having just from the scale and frequency that you can test when you have dedicated volunteers going out regularly, particularly when they're skilled enough to work independently. So Mike has effectively led the whole thing on that front. And increasingly, we're hoping to bring in some smaller groups, so to have people to sort of support community monitoring already going on within the area, and have groups established that can work a bit more hands-off, but ultimately feed into the partnership and answer specific questions. So on the water quality front, we want to make sure that we've defined our questions well, and that we know what we're looking for to be able to tackle those. And I think there's often the outlook that more monitoring is always better, but in practice, it has to be monitoring that answers the right questions. We're definitely finding that what we've done so far has built a really good picture. Just making sure that the effort is well spent. So our main, we've actually got quite a nice separation in our targets and our problems. That sediment seems to so far mostly be linked to agricultural runoff. So working with farmers increasingly to try and mitigate that. We've got a meeting next week with the Upper Pang Valley Farm Cluster. So that's all of the arable lot towards the top end of the catchment. We're hoping to be able to support them through the Pang Flagship Chalk Stream Partnerships funding to put some mitigations in place that they can't already get funding for around environmental protections. Then thinking about nutrient reduction, putting pressure on Thames water through the partnership to put phosphate reductions in place towards the top end of the river. So those two wastewater treatment works that are frequently the source of the Pang, the Hampton Norris one and the Compton one. Hoping to see those. Well, there's a target for one of them, for Hampton Norris, to have 2.5 milligrams per litre of phosphate P by in the next WINEP cycle. So by 2030 to have that implemented. We would like to see more stringent targets, definitely lower levels, because ultimately, if nutrients aren't limiting, then it sort of leaves climate to potentially play havoc if the river does warm up and there's a lot of light. There's plenty you can do on the ground as well to get good shading of the deep sections, but ultimately it's something that needs to come from the water companies as well as potentially from private riparian owners with septic tanks, which we're developing something of a plan for. And then hazardous chemicals, anything that goes down the drain, of course, can have an impact, particularly if it's insecticides or runoff from fields. But road runoff could, waiting to hear back on our results in the next week or so from the M4 testing, but definitely expect to see a lot of heavy metals that are particularly detrimental to riverfly working their way in there. So in terms of action and what we can actually do about it, we've had a walkover of the River Pang. I think it is important to keep monitoring in the context of supporting physical works as well, both in sort of demonstrating efficacy and in implementing something that will improve water quality ultimately. So getting the river back to its natural course, having wetlands that can help things settle out can only help. So we've got a plan in development, got detailed designs and working on getting consents, etc. at the moment for a wetland downstream of Hampstead Norris Wastewater Treatment Works. The plan is to work with UKCEH on this, fingers crossed, for them to do some spot sampling to support our continuous monitoring that we've already got, and to put one towards the top end of the wetland, one towards the bottom end. The setup here is that the outfall currently goes directly into the River Pang. So we're going to change the main course of the river so it runs a bit further back, and instead goes into a wetland cell. You get the right balance of sort of slow flow and wetland plants to then be able to process some of this, allow sediment to settle out, allow less so sediment, more some nutrients to be taken up over summer, which will ultimately phosphate from get released over winter, but they're less likely to cause an issue at this time of year, and also provides some great habitat in the river and will mitigate things like ammonia quite effectively. There are also some very simple interventions you can put in place. So for things like, working with farmers hoping to identify spots where water would go directly into a surface water drain, but actually just taking a bite out of the sort of road buffer can allow water to instead flow through a field designed to a good riparian buffer, or a field that's permanent pasture that can let some of that settle out and acts as fertilizer instead of act as a pollutant within the river. Can be quite simple mitigations. And also looking into, we're going to be deploying some sediment tubes. So this is a bit of pipe. It's quite a simple setup. It's effectively a pipe with a funnel at either end of it. So it's a narrow 4mm aperture either end, 10 centimeters wide and 1 meter long, held in place with a couple bits of rebar over the top of it. And that then allows sediment to settle within it. So you get a sediment sample. This I think I left in there for all of one day, so we didn't collect very much. But it gives a good indication of sediment levels at different points along the river. So you can tell if one tributary is more of an issue than the main channel, for example. And also you can take that sediment and we're hoping potentially to work with Rothamsted on doing the sift process, which allows you to a degree, trace where sediment's coming from, something that's got potential, is quite a lot of work, but could be a good way to identify if, for example, it's coming from arable fields, permanent pasture, or the riverbanks through a sampling process. Last thing quickly is a wetland that we have put in place. So the Wilton wetland out in the Kennet catchment near Crofton was developed, well, near Wilton as well, was developed in 2022, delivered in 2022, working with a landowner there who, and yeah, we found it's been a really effective mitigation in reducing runoff from this quite large catchment. So this whole area flows into, well, this area flows into 3 of the wetland cells and this area flows into the 4th. And found that as you go downstream, phosphate levels generally decrease quite dramatically. There's not nearly so much in the bottom cells at the top, apart from this 4th cell, which takes this vast catchment in. And then it ultimately runs into a pond and into the Kennet. And we've had ongoing testing by a bunch of farmers in the area who have found that using sort of nitrate and ammonia, phosphate and ammonia checkers, and they've found really improved levels downstream than beforehand, which is very encouraging. So it does seem to work for water quality, and it's fantastic habitat. Really diverse selection of plants out there at the moment. Nice sort of ragged robin and all the rest of it growing in there right now. Also created a wetland at Sulham. So this is just next to Pangbourne. There's the River Pang over here, Sulham Brook adjacent to it. It's a seasonal wetland. It sort of ran dry for a few weeks this year already. Mostly groundwater fed, but has some surface runoff come into it as well. And I thought I'd just sort of end on a nice note. We had volunteers out there to plant it all up. I was visited by Lapwing quite early on. So almost as soon as it was constructed, the lapwings have started moving in. Did some plug planting, which some of which has survived, but we've had definitely mixed success off the back of it being such a ridiculously dry 2 months immediately after planting. We sort of put them in the ground and then didn't rain for all of 8 weeks, which comes with its own challenges, and there's definitely climate change in action. We don't get a single April shower. But all the same, the wetlands established nicely and has some life in it. It's a tiny little lapwing chick just filmed last week out there. So some of the brood has made it, which is very encouraging. I think that's all for me. But any questions? Yeah, please do shoot. Thanks.
Brilliant. Thank you so much, James. That was really good. And what a great way to sort of kick off the Lunch and Learns. It's really informative and really good. Does anybody have any? We've got a couple of minutes for questions left. Does anybody have any sort of questions anything they want to ask James whilst he's there? Are you coming in there, Mark? Oh yeah, go for it, Mark. Might need to unmute yourself. Yeah.
Sorry, I know it's a bit cheeky, James, but I just wondered, would it be possible to deliver that presentation at our Darren and Craig Catchment Improvement Group at some point?
I'd be very happy to if I can. Yeah, if I can find half an hour, would love to.
Excellent.
Thanks,
okay, brilliant. If you could drop your email address in the notes, I'll take a record of it.